Welcome, we are a team in collaboration from the International Institute of Information Technology and the University of Bath, and today we will present our work, FaceOff, a video-to-video face swapping system. Do you remember this famous scene from the movie The Social Network directed by David Fincher? And did you know the twin brothers are actually played by a single actor, Armie Hammer? At the time of the movie shoot, one of the brother was always a body double. The scenes are then later edited in post-production where the face and the expressions of the main actor are superimposed on the face of the body double. Please note that here, the pose and the background of the original video is still retained. One can consider computer vision face swapping techniques as an approach to automate this task. However, one important requirement in actor double face swapping is the transfer of expressions from the source video of the actor to the target video of the double. Thus, one cannot naively use face swapping for the task. To tackle such tasks, we introduce video-to-video face swapping, aka V2V face swapping. FaceOff takes two videos as input: the background and pose of the target and the foreground of the source face video. FaceOff then takes both of these videos and inputs and generates a coherent and meaningful output meeting all the required constraints. We use a hard distance loss like Euclidean distance to compute the loss between ground truth and the output in a self-supervised setting. In this setting, we use a single video to generate the source and the target. The target is the background and the pose extracted from the video. The source is generated by first extracting the foreground of the video and then adding random errors. The inputs are then passed through FaceOff. FaceOff is expected to fix these random errors and generate back the original correct video. Now, we look at some outputs. Please note that all the face-swapped outputs we will see are all on identities unseen at the time of training. In this example, we swap faces with drastic differences in facial structure and expressions. In this example again, the source and target have very different facial structures and head motions. Even though the head poses have changed, FaceOff is able to generate a coherent identity and pose in the output. Here we show a real-world body double swapping example. We simulate this setting with the characters from the famous sitcom The Office. Here, Nolan, the actor, recorded his videos at the convenience of his home. Jim is acting as his body double. Now we show comparisons with the state-of-the-art face swapping models. As can be seen, FaceOff swaps the identity better than the other two models. It also perfectly swaps the source expressions. Whereas, the other models do not swap any expressions, target or source, exactly. We show one more example with crossgender. Despite the drastic change in the overall face structure, FaceOff successfully swaps both the identity and the source expressions in a coherent manner. Unlike FaceOff, the existing models fail to fully swap the identity and have unnatural eye movements. We show some results on V2V face swapping for the same identity. Here, we show such instances. As can be seen, the identity is perfectly preserved along with the pose and background. Only expressions such as the eye and lip movements are swapped from the source. V2V face swapping is an important task with many real-life use cases. We propose FaceOff, a video-to-video face swapping system. FaceOff is a temporal autoencoding network that works on any unseen identity directly at inference. Thank you for taking the time and listening to us. We hope to encourage research in the direction of V2V face swapping as it is an important area that needs to be solved.